Welcome back, Module 6, our final one of the day. I am Rich Curry, still and will continue to be. George Squillace, still and will continue to be. George, what do we got coming to end things up today?
An interesting and a really vital topic to a SQL database administrator, the topic of high availability. A bunch of different things to take a look at within high availability. We'll first have to take a look at what high availability is and the particular kinds of things that it covers. And then we're going to drill down into a number of different high availability technologies.
All right. So
now, I want to be clear. A couple of these are really not covered on the exam whatsoever. That's not so much the relevance. Like, for example, replication. Not really covered at all on the exam, but because the topic is high availability, I want all of you to have a decent big picture look at the availability options that are within the product. So I'll have an inclusion of all those, at least a little bit, for your sake, not so much for exam purposes.
So let's start out. What is high availability all about, George?
When I'm trying to protect my environment, I need duplication at some level or levels. So high availability refers to having something available after some form of failure.
So if a machine crashes or if a disk file breaks, disk drive breaks, something along those lines.
So I could have media failures, I could have complete server failures, I could have complete data center failures. There are failures really at a number of different catastrophic levels. So we have different kinds of high availability technologies. Some protect against hardware. Well, one in particular, failover clustering, or what I'll call traditional failover clustering, protects against hardware failure. I have a lot more to talk about there, so we'll save the more detailed explanation until later. Okay. Now, in particular, there are multiple technologies that protect against media failure, the loss of a database file, a LUN, things like that. And so we'll see that all of these involve duplicating database data, the entire database, or a portion of a database somehow.
Okay, so what's the first one that we want to talk about?
Okay, so the first one we want to take a look at is replication. And what you want to picture here is Grandpa's old cottage. This is something that's been around for a long time. It's tried and true. It's loved. It's useful. To tell you the truth, though, replication's a handful. It's very highly configurable, and there are a lot of ways that you can architect it. Rich, you know you're in trouble when you go to look up books on replication, and you see that any of the books, that there are only a couple books available on it, but they're over 500 pages. Simple Talk is coming up with a free ebook on replication. Should be out any time now.
That's a good thing, because I don't care what you're doing. Replication, at some level, you're probably going to have to deal with it in your SQL Server career.
And not only that, but it's probably going to get tangled at some particular point, and you're going to have to learn how to untangle it as well. Now, every one of the topic areas in this module is going to have a general pattern, like what are the facts, the basic technology that it uses, or movement or duplication method. Then, what are the hands-on or general hands-on processes for implementing it? And then, not a single one of the technologies is perfect. Every one has something glaring that's omitting or some potential drawback. And that's even true with the very newest technology, which has a lot to love, and that's AlwaysOn technology. So let's get busy and take a look at replication.
So let's start out with the basics. What's replication all about?
Okay, replication allows me to identify objects within a database, specific objects, which we call articles.
Okay.
These could be things like tables, even a filtered table where I have a portion of columns, a portion of rows. So we'll refer to that as a portion of an object or a whole object. And I have a collection of articles that are then contained within a publication.
So kind of like a magazine and the articles in a magazine.
Yeah, and then that is made available to one or more SQL servers. So the machine which is making the data available is a publisher. The machine which is consuming it is a subscriber.
Okay.
And in a more elaborate architecture, there will be a role somewhere on the publisher, on the subscriber, or maybe even on a separate box that is doing the data movement, and that's called the distributor.
So kind of like the U.S. Postal Service sometimes.
Sure. The distributor can be on any one of those machines, and in a larger environment, I might have a dedicated distributor.
Okay.
Now, as far as data distribution, that's part of what this is all about, data duplication, data distribution. You're going to see a graph on the slide here which illustrates a balancing act. So we have autonomy versus latency. Now, there are times where I might have a copy of a database or a copy of an article, and I want it transactionally very consistent, not perfect, very consistent with the original object. And notice that moves us towards very low latency, but if we happen to lose a connection between the two machines that are replicating, then we have no autonomy, so we're going to have a problem.
So very little time for them to have to be in the difference between them, very little time to make them the same again, but there's a high dependency between each other.
Exactly. Now, on the opposite end, we have very high latency that allows maybe a lack of connectivity for an extended period of time, but no worries. Maybe I don't need the latest data. So we have other ways of being able to handle that. High autonomy, but also with high latency. Now, I don't need you to memorize all the terms in between the two extremes. Just realize you have a lot of choices.
Oh, yeah.
There are a lot of ways to weave this, and I have a lot of respect for those that wrote the code to get all of this to work.
In one of my previous lives, George, I had 120 databases that we were synchronizing data with, going through with replication in different levels, and I got to tell you, it was a lot of work. It is a great technology that requires a lot of attention.
Okay. Now, I've already stated what some of the possible articles are. I could have a complete or filtered table, but there are some other objects such as a stored procedure that produces rows, a view. Now, a curiosity is that whenever I pick an object with dependencies, like a view or a stored procedure, the underlying objects come along with it.
Okay.
Whether you have to select those two. So in the process of configuring a replication, I have to determine a schedule for how frequently I will want the propagated updates to go to the target or subscriber. And in this case, agent services are going to have to communicate with other agent services. So whether you use code or the graphical user interface, you're going to have to configure agent security. These are the basics of replication.
So what are the broad types of replication available?
You'll see on the next slide that there are a number of different replication types, and I've shown you one of the wizard steps involved in setting up a replicated set of objects if you use the wizard. So we have snapshot, transactional, and merge. Those are the broad types, and notice we have two different kinds of transactional replication. So with snapshot, I'll have a large amount of changes, maybe let's say 80% of the data in an article changes from cycle to cycle. So rather than tracking the individual changes moment by moment, we just take everything wrapped up in the publication and replicating it.
So it would be like taking a picture of your kid once a week and replacing it in the frame.
Exactly. That's a good analogy. Now, on the opposite end, merge replication would be like, if you're familiar with domain controllers, I might have 3 different Active Directory domain controllers, each holding full copies of the object, and if an object changes in one copy, then that's going to change in the other copies as well. Transactional replication would be when I have some modification, I want that more immediately reflected in a destination. And like I said, there are many configurable options with this.
So how do I implement that? What are the different steps that go into it?
Well, taking a look at implementing replication, there are lots of things to like when it comes to high availability because I'm duplicating data. You'll notice it can support not only one subscriber, but I can have multiple subscribers for one publication. So I can have even more than one copy.
So I could take data from one spot and send it out to a whole bunch of different servers.
A bunch of different servers anywhere on my network. So this could be geographically distributed. That's what I'm trying to point out in the lower right part of the diagram. So different IP subnets, different SQL servers, even in different data centers. Now, there's no automatic failover. So if I'm pointing an application to some data on one machine and it fails, there's absolutely nothing that causes or redirects a client. This would be an entirely manual process, and it depends on how the application makes a connection. If you can point to a different IP address or change the connection string of the application, that would dictate in part how you would perform failover. So there are shared folders where replicated updates are stored. The distributor will pick them up there and then move them along. Lots and lots of moving parts here.
Cool.
So let's take a look at the strengths and weaknesses. A strength, replication's been around for a long time. So it's tried and true. You've said you've used it
Absolutely.
a lot. Lots of configurability. I don't need any specialty hardware, so I can have completely different hardware configurations. One is a publisher, one is a subscriber. As long as they can handle the workload, that's fine. I can span data centers, which covers a catastrophic data center loss. And I can have multiple secondary copies. And depending on the replication method that I use, they also can be locally modified and the changes replicated back.
But what about weaknesses? What are the things that might keep you from choosing?
They all have a price, right?
Absolutely,
So
everything does.
we saw no manual client failover, and in fact, depending on how my application makes a connection to SQL Server, that could really be a handful. So you need to look at that for your own environment. Also, this is not really a system data kind of protection. This is for user data, or user database data. And unless you select every single table in your database, it's only partial database protection.
Okay.
And by the way, you're not going to likely select every table for replication.
No.
Tell me your own opinion. Just so I'm looking for an opinion here. Have you ever gotten replication really tangled up and it really caused some snarls to get it back up and running?
Frequently, one of the things that we ran into was when you had a problem with replication, just about the only choice in some cases was to delete it and start it all over again.
So you killed the subscription and started over. Yeah, I've heard of this as a plan of attack. Do we call it?
Yeah, one of the things that is highly recommended with replication is that when you do set it up and configure it, that you script out the replication and save those scripts, because that will make it a lot easier.
Excellent. Good piece of advice. All right, so next up, if you guys would flip to my screen, we'll take a look at how we would walk through the publication creating process. So I'm connected in Management Studio. You'll notice there's a replication node, and from there I can choose New Publication. No surprise, I get to a wizard, it welcomes me, and from there I have to dictate where the distributor in this architecture will be. So with this particular architecture, I'm saying that the publisher will also be the distributor. Remember, lots of different choices there. So after that, we'll find that there has to be a folder designated where updates can be found that the distributor will pick up on and then move to a target location. So if there are enormous amounts of updates or you have a number of subscribers making connections, you might want to make sure that you specify a place that has enough space. Now, another thing to keep in mind compared to our other technologies, all of this occurs within a single database. So notice, as far as the scope of protection, we're actually inside the boundaries of the database. So I have to pick the database within which I want to replicate, and then this should look a little bit familiar.
Yeah, I saw that one earlier.
Now, think about this. There are certain doors you go through in life. The door slams behind you, and there's no knob on your side.
Okay.
And similarly, when we change the publication type, that's a door we don't go back through. There are several other choices. You step in a bear trap, you have to rip the subscription or publication out in order to make a change.
So once you've set it, that's about it. Okay.
You're going to have to stick with that.
All right.
All right, so next up, this is important. You'll see this is the list of articles. You guys got to go back to my slide, thanks. You have to pick from within the boundaries of available articles. So you can read, we have tables, stored procedures, but notice that we have the plus signs next to a couple of the objects.
So we can expand those and see the individuals on each one.
And in fact, on a column by stinking column basis.
So you don't even have to do a whole table.
That's right. So I don't have to do all columns, but in addition, let me get up to this next part, I also can filter by rows. So seriously, what if I have a table that has a bunch of data from a bunch of regions, and I only want the the American region or North American region? So I can essentially write a where clause here, and from the where clause determine only that data which I want.
That is pretty cool.
Granularity is the big deal here. Now, there is a potential to have more than one subscriber. We saw that as a strong point. So after we've configured this, we have a place where an additional subscriber can go to pick up changes, and also on an ongoing basis for those current subscribers. And now I'm at the snapshot agent, which sets up on what regularity will a publication or will a replication cycle occur. So this is going to end up creating an agent job and use the normal agent job and scheduling process.
So a snapshot is only going to update when the agent tells it to.
Exactly.
Okay.
And for agent security, depending on what particular type of replication I'm going to use, I'll have to make an association of the agent in one instance to the agent in another instance. I just wanted to see that, not necessarily all the gory detail. Now, towards the end of the wizard, notice it asks me, do I just want to script, but I don't want to do it?
Okay.
Do I want to create the publication, but not script, or what Mr. Safety would do?
Absolutely, you do them both.
I'm going to do both. And from there, it asks me more questions. Basically, how do I want to create the script file? So, do I want to append the new script file to an existing? Maybe I have a whole batch of replication script code that I want to have, and a couple of other options there. And then finally, complete the wizard. I name my publication, and then it gives me a status update.
Awesome, George.
There you go. So after that, I would then see in the list of publications, I would see a publication.
Awesome. Awesome. So replication, all about getting data from point A to point B. It's more about the movement of the data than it is about everything else, right?
Yeah, and also the fact that I can very carefully control the type of data and the frequency that I want to send it. So I think replication really isn't considered a pure high availability technology, but it's duplicating data.
So if I move one step closer then, and I want a database to be more tightly coupled to its replica, what would I do there?
Well, let's take a look at the next technology, log shipping. Again, log shipping is a tried and true technology. Let's go to the next slide. We'll take a look at the big picture here. So we have the same pattern that we'll look at for log shipping that we did in the other, or in replication and the other technologies too. The basics, how we put it together, how failover works, and a strength and weakness comparison. Now, if you'll go back for just a second, one of the things that you'll see here in the screenshot, I've gotten properties on a particular database, and you'll notice at the bottom we have log shipping as one of the pages. What is the key place to get that started? Well, of course, enabling it. So let's go on to the basics, and I want you to focus on the diagram here. We'll say that right now I have SQL Server 1 in the upper left, and it's serving the production copy of a database.
Okay.
So I have maybe a web app, a Windows app that's used to make a connection to that, and so I'll have clients on a network probably close to that machine.
Okay.
So now I run through the log shipping configuration, and a bunch of moving parts are put in place. First of all, this primarily applies to user databases, but the entire database, its schema, and its data. So this is clearly a high availability technology.
So no longer do we have the ability to choose individual objects to filter out data. It's all or nothing here.
Yeah, it's all or nothing. So as I walk through the wizard, first I create a schedule that says, take the transaction log of the current database, back it up generally pretty frequently, and then store those transaction logs in a shared folder, preferably that's nearby.
So does that schedule for the transaction log backup, does that drive the latency between the two databases?
Definitely. And in fact, before we get done, we'll see there are several schedules that can be carefully crafted so that you get exactly the latency that you want. And this can very much work in your favor. Hold on to that thought for a second.
Hanging on, baby.
Right. So next part of the wizard, we have to determine on what level of frequency we'll take the backed up transaction logs close to another shared folder that may be in the same data center, on a different SQL server, on a completely different subnet, completely different area of the network, meaning a different geographical location. As long as the SQL agent can connect to UNC share, it's reachable. So in the worst of cases, we could have a data center failure, and as long as all our mission-critical databases were log shipped to another destination, all that data's there. Everybody say, ah.
Ah.
We're not done yet, though, Rich, because
there's more.
Now we have a third schedule, and the third schedule, and by the way, these can all have different time frames. That's part of the point.
Okay.
So I can back up, let's say, every 10 minutes, take those backups every hour in one folder, copy them to another folder, and then the third schedule basically does a perpetual mini restore. So it keeps the transaction logs restored over the top of the destination database or databases, because I can actually have more than one copy of a log ship database. That's good news.
Absolutely.
And in fact, this is strategic. I could actually have different restore schedules, maybe one aggressive and one not aggressive, so it could account for maybe a DB, I have maybe a 4-hour delay with one log ship copy, and in that case, it's not going to receive an error for hours based on that. That may help me position well in a recovery situation.
That's pretty cool. Now, is the recovery the only thing that you can use log shipping for, or are there other things that you can do with a log ship database?
Well, one point to bring out is that with the database there's a setting that says what is going to be important, allowing read-only querying of the destination log shipped copy or the backup job, the restore job. So one of those is going to win. So let's picture something.
Okay.
Let's say I have a connected user that's read-only querying a log ship copy.
Okay.
One of two things is going to win when the next restore schedule comes up. Either the user that's connected in querying is going to be allowed to win and continue querying until he or she is good and done, or the backup job says, honey, I'm home, boom, comes in, does the restore, kicks out the connected user. So which one are you going to pick?
It depends.
Excellent. That's the answer to every consultant's question. You fell into that trap perfectly. Alrighty, so that's the essence of log shipping. Lots to like about it. So now that we take a look at log shipping, let's go to implementing it. So I can configure this in Management Studio. You'll see an example of this coming up. And there are lots of stored procedures that can weave all of this together. I didn't mention this. I think there are over 100 stored procedures just related to replication.
So
whatever, a whole bunch.
So let me guess. Given a choice, I'd want Management Studio to use its wizardry. All right, so it's late in the afternoon. I apologize. Keep going.
No. So I can use, as a matter of fact, if I script the whole process out, these are the stored procedures that I'm going to see.
Awesome.
I have to have a recovery model that can use the log file, and more than likely, this is going to be the full recovery model. And so looking at the architecture diagram, we see that a backup job is going to have to be created. Multiple copy jobs, or I should say a copy job, and then restore jobs to perpetually restore the database. There is an optional architectural element called a monitor server, which can be queryable, and it doesn't need to be any fancy addition either. I can have that as part of the architecture too.
And what does the monitor server give you?
Why don't you run with that one? How's that for tossing the hot football?
Okay, so you're going to put me on the hot spot. So the monitor server is going to watch the process, and then if it fails, if the primary fails, it's going to help me fail over?
No, it's not going to help me fail over. It's really more of a tattletale object, honestly. So there is no manual failover whatsoever with log shipping. And in fact, let's go over to Failover Basics where we can take a look at this. So if I have a failure, it depends on what happens to the source. If I have a catastrophic server loss, well, that's going to I sure don't have any transaction log data there to grab.
Nope.
So if I happen to have a problem where maybe the machine is still available, but the SQL Server service is not running, or there's some damage to the database, at least grab those most recently backed up transaction logs and copy them near to where I want to recover. So back up the primary database log with no recovery. That's going to capture the tail of the log too.
Okay.
So I'm going to bring all of that data over, and I'm going to perform a normal database recovery on the destination. It's going to have some jobs associated with being a secondary. Disable all of those. You may want to leave that or turn it back on later. So don't kill the jobs.
Okay.
Just disable them. And then what you may want to do is to establish high availability at the destination. You're going to want to configure log shipping on that machine. But what do you do with clients?
You got me on that one, George.
So a couple things that you could do with clients. It depends on how the application is architected. So if the application has a connection string that points to an IP address, well, you can change the IP address of the destination. That's one way. Another way you could do it is if your application connection string points to a DNS name. Well, you can change the IP address in DNS, and then clients are redirected transparently as well. So there's not a perfect transactional failover while somebody's using the log ship machine, but those are some of the failover options. So notice, totally manual intervention, but there's opportunity for being graceful.
And for log shipping, just like with replication, there are strengths and weaknesses, right?
So strengths, it's been around forever. It's
That's
mature.
a good thing.
A lot of people know how to use it, which means you might be able to get help untangling it. You have multiple copy jobs and restore jobs with their own schedules. So I can have more than one copy, and like I mentioned before, maybe one aggressive log ship copy doing a perpetual restore, maybe only a few minutes behind the original server, the production server, and maybe another copy that's a few hours behind, just to help. It's not, as you'll see from the demonstration, not too difficult to initially configure or manage, and no specialty hardware. That's
a good thing.
Now, because copy jobs can move from UNC path to UNC path, this means anywhere in my network where I have access, I could even span geographical regions.
Okay.
My secondary database is read-only queryable based on how I have that set up. And alert jobs can be set up if a replication cycle doesn't occur. I said the R word. If I have a failed job, either in restoring or copying, and it doesn't occur within a certain threshold, I get an alert. Everybody say, ah.
And what about the weaknesses? What are the things we need to look out for?
So manual failover as described. This also has to be configured on a per database basis so it doesn't protect the entire instance. And it can't protect master. So you're not going to turn the full recovery model on master. So that is in, what would you say, unprotectable database?
Yeah,
we'll go with that.
Like it.
Okay, so let's take a look at log shipping. If you guys will zip to my machine for a sec. Actually, hold on for just a sec.
You were a little bit late on that call there, George.
Okay. All right. So taking a look, I'm looking at properties of a database, and the point to focus on is the recovery recovery model. I have to have something that has logged transactions that are not going to be overwritten like in the simple recovery model. Now from there, I'm going to go to the transaction log shipping page, properties of the database, and after I'm in the right recovery model, what do you think I'm going to do?
That checkbox that's sitting there staring at me looks like a good place to start.
So that's like kicking off the domino chain. After I click on enable, a whole bunch of action occurs. So enable this as a primary database. This will be the production database copy. And then I would click on backup settings. I really don't need to look at that. That's just going to set up a job with a schedule. Okay. So that's really business, business as usual.
Squeaky over here doing the demo.
Yep, squeaky squillace. So transaction log backup settings. So transaction log backups are performed by an agent job running on the primary. I'm going to have a place, a shared folder where I'm going to place my backed up transaction logs.
And that's where the partner servers can go and grab it from.
Yeah, now I actually could do this two ways. I could have one folder for storing the logs and then copying those to another folder nearby, or I could actually specify that they're the same folder.
Okay.
So, consultant, how are you going to pick?
Let's see. It depends.
It depends. I would say if they're geographically distributed, I would pick different folders.
Okay.
If they're in the same data center, then maybe, big deal. What does it matter that they're different?
It's probably going to be the same server anyway. They're going to have easy access.
Lots of controls here, so I can delete transaction logs that are older than a certain time, get an alert if no backup occurs within. If I want to carefully have naming conventions for these related jobs, fine, I can do all that. So after that, let's see. I think I just did that. So let's go here. So again, business as usual, job schedule. Sorry, didn't need to go there. Okay, next up, I now have the secondary database settings. Now I have to point to the instance where I want to have this database, and the database names don't actually have to match. Please, Rich, keep it straightforward. Have the same database names, and this would seem to make sense, but now I'm in the first tab, initialize the secondary database. Do I want Management Studio to restore a backup? So I may already have a database copy there. Maybe it's already there. Or I can actually set up the process right here and now.
Okay.
So after that, so did I jump ahead here? Let me see.
No. So you set up the database, you set up the destination, you're specifying the locations, right?
Yep, so specify locations. If the secondary database will be created when the backup is restored, specify the place for data and log file. So
okay.
That's if it didn't already exist. So next up, I'm in the middle tab, copy file. So this is where I could specify a second folder if I wanted to, or point to the original folder where I had my backup jobs.
Okay.
My normal inclination is to have separate locations. And if anybody has a lot of experience with this and has a strong feeling on the matter, it might be interesting to see what some of the posts are there. But I set up a UNC path here, and again, delete copies after a certain threshold of time, have a copy job name, set up the schedule. So all that, of course, is independently configurable as well. So we don't really need to look at schedule. Now, finally, we're on the last part of the configuration, and you'll see two radio buttons there, which answers the question, what's going to win? Do I want users that are querying the database to have precedence, or do I want the restore jobs to have precedence and cut out those connected read-only users? Notice I have delay restoring backups at least a certain amount of time, alert if no restore occurs within, and then again a job name.
So the three pieces are, how often do you want to back it up and where do you want to put the backups? How often do you want to copy them and where are you going to copy them to? And then how often do you want to restore and will you let people query it?
Excellent summary. And so finally, if I wanted to monitor server, Yeah, I'd have to go through some of the same configuration there. How I'm going to have the agents talk to each other, which instance is going to do it, the job that will handle it, and then I'm at the end of the wizard.
Cool.
So that's basic log shipping. Now, it's really beyond the scope of showing how to perform the recovery, but there are lots of good references when it comes to rolling over or taking a secondary server and putting it into production.
So the key there with log shipping is that we've got the ability to control the schedule of shipping, but there's still a time lag there, and we really don't have any failover capabilities. What's the next step in the progression here?
Let's see, did we take a look at strengths and weaknesses of log
Yes,
shipping?
we did.
We did. Okay, so next up, exactly like you said, having something that's a more automated failover, and that's database mirroring. So database mirroring entered the picture in SQL 2005, and it was a very exciting feature at the time, namely because a technology we're going to look at, failover clustering, was there. And it has certain strengths and advantages. Log shipping has its strengths and advantages, and neither of them addressed what mirroring did at the time. In the very, I have to give away a little bit of the end of the movie. In the very worst case of failover clustering, you could have a very long failover time. Automatic, but it might be long.
All right, well, let's hold off on that.
Yeah, we'll have to hold off on that and take a look at mirroring. So same general pattern. What are the basics? How do I set it up? Strengths and weaknesses, etc. So let's go, let's take a look at the basics. So I have one instance, we'll call it the principal instance, and it's serving a production copy of the database.
Okay.
Now, with newer .NET technologies that were out at the time, I don't remember what .NET version, maybe even 2.0 back then. But anyway, that's immaterial. So with a newer .NET connection string technology, you could not only have a primary a connection string, but an alternate server name in the connection string. And this is part of the automatic client failover trickery.
Okay.
So I have to have a recovery model. I don't know if it has to be full, but you would only set it up in full. You wouldn't even use bulk log. And essentially it works like this. I have a secondary server, and on a transaction by transaction basis, I have transactions going over the network, maybe to the same data center, maybe anywhere where I have IP connectivity in my network. And picture people marching together, left, left. Transactionally, each copy, transaction by transaction, are kept consistent.
So it's almost like log shipping with no delay.
No transactional delay whatsoever because, well, actually, with 2 out of 3 of the options, one of them actually allows a delay, but hold that thought for a sec. Okay. So I have perfectly transactionally consistent copies of my database. Now,
but we're still on a one database at a time instance.
Yeah, this is
right?
This is protecting on a per database instance. Now, there's some overhead here, Rich. The database destination is inaccessible. It's considered to be in a perpetually recovering state, and so unless I, please don't keel over here, unless I set up database snapshots, which could
dear.
Be, and they're not bad. They have a place. I like snapshots. Yep. But that is the only way that the destination copy is queryable. So am I going to set up mirroring on maybe, a 5 meg database?
Nah, I wouldn't.
I'm going to set this up on something that's more mission critical, which means I probably allocate a secondary box for this. So I might specify, another 5, 10, 20 grand server that basically is not serving another role unless something goes wrong.
A just-in-case server instead of a just-in-time server.
Exactly. All right.
So how do we set this up? How do we configure mirroring?
Alrighty. So looking at the configuration options, there are 3 possible ways we can set up mirroring, and I want to focus on the one that really is the jazzy one, the one that is provides the best amount of high availability, and in fact, immediate, within 10 seconds failover guaranteed.
Sounds like a plan. If I'm doing it, I want to go for the best.
So I have a primary server, I have a secondary server, and I configure objects called endpoints, which for all practical purposes are listening ears that one machine uses to send transactions to another TCP/IP endpoint. So it has a port number. I'll configure authentication, probably configure encryption, so that I don't have to worry about that data being intercepted.
Okay.
I have a second, so that's the primary and or the principal and the mirrored copy. I then also have a tattletale or a tiebreaker, and this is absolutely necessary for the automatic failover. It produces, well, a tiebreaker or quorum.
Okay.
So in the circumstance where the principal's unavailable to serve its role, you have to have quorum between the mirrored database and the witness, and within 10 seconds, the mirrored copy and the witness agree that there has been a failure. The final transaction is rolled back, and the secondary copy is put into production that quick. Now, that covers database failover. What about client redirection? Well, remember, in the newer, well, it was new back then, in the newer .NET connection strings, they also could list a secondary server. So client connections, after they had a hiccup connecting to the first one, you'd set up a retry, and they'd automatically reconnect to the secondary copy and be put into production.
That sounds pretty cool. That sounds pretty cool. Are there any geographical limitations or anything like that? Is mirroring restricted at all?
No. In fact, as long as I can reach from one machine to another via IP, then mirroring is a possibility. So this would cover, a catastrophic data center failure as well.
So theoretically, I could put it on a public internet IP address and mirror across outside of my own domain even.
I probably wouldn't do that. Probably I would have either tunneling connections, VPN connections among my sites, and this would be within my own personal network.
Security always comes first, doesn't it?
So mirroring strengths and weaknesses. One of the biggest advantages is that I have automatic database failover, automatic client failover, and within 10-second recovery.
Okay.
So those are some of the strongest features about it. Honestly, as you'll see, it's really not that tough to initially set up, especially if you use the graphical user interface.
Cool.
Now, log shipping we saw didn't require any specialty hardware. The other high availability technology at the time did, so that made mirroring look really nice.
Okay.
No specialty hardware. I can have mismatched hardware.
That's always a good thing.
Different CPUs, different memory, different vendor brands. None of that is material when it comes to mirroring. So weaknesses. Uh-oh.
Uh-oh.
The D word.
No.
Mirroring is deprecated. It is a dead man walking feature.
Please tell me, I'm going to try and give away a little bit of the end of the movie.
Go ahead.
Is there a replacement?
Thankfully there is a replacement. That's
and we're going to be talking about it, right?
We will, hopefully real soon, but yeah. So it's deprecated. I have to have 3 servers. I don't need 3 servers with log shipping. Have to have 3 servers in order to get high availability mode.
But the witness doesn't have to be anything special,
Doesn't have to be anything special.
Okay.
Mirroring has to be configured on a database by database basis. So if I had 10 production databases that I want mirrored, I'm going to have to configure mirroring on behalf of each and every one.
Okay.
So now let's multiply that. If I had 100 or 200 databases on an instance, that's going to be a lot.
All right.
Finally, no system database protection with mirroring.
Okay, so replication can't be used to protect system databases, log shipping can't be used, and neither can mirroring.
Nope.
All right.
This brings us, let's take a look at how we implement mirroring.
Absolutely.
And actually hold off on the screen for just a second while I get some things arranged. Okay, roger that. So I start off the same way I would often when in doubt, right-click. So I'll get properties of a particular database, and additionally, I still have a mirroring page.
Okay.
So I go to the mirroring page, and how about if I start up at the top? Configure security.
So they have to be able to talk to each other, and there's security involved in doing it.
Yeah, so if I'm shipping transaction logs, transaction by transaction, something has to do it. It is the agent the agents have to talk to each other. So when I click on that button, yep, I'm going to have to walk through a wizard to configure how those agents will communicate. So after I start the wizard, it asks me, do I want a witness server? And remember, for the highest level of availability, the fanciest option, yes, I must have a witness.
Okay.
So after that, I have to involve the particular servers to configure. So now that I have identified that I do want a witness, I continue the wizard this way. So now configure the principal, meaning if I said that I want to have a witness, of course I have to configure the principal, of course I have to configure the secondary, and yes, I do now want to configure the witness, but first up is the principal. Now an assumption is made, if I started at a particular instance in a particular database, it must mean that instance, and I can't change the name right there. I can change whether or not I want encryption, and I probably want it. I can change the port, and I'm going to have to communicate with my firewall folks if I have VPN connections from site to site and I want to have cross-site mirroring. And an object, a listening ear object, is made called an endpoint, and I may have naming conventions I want to adhere to, so at least I get the ability to name that.
And that port is not the database engine port. It's a separate port that's set up specifically for mirroring, correct?
Absolutely. Now, a little bit of a fluky thing here. When I was running through this, I had all, don't do this in real life, I had all three instances on one machine just to reduce some of the moving parts. And that's why listener port 5023 was suggested. I can't have the same port used on the same machine.
Yep, makes sense.
Normally I'd have the same port across all of the machines, but I can't do this within one machine. So that's why a separate listening port was suggested. So I have a second instance, a different port, and an endpoint name. All right, from there I have to validate identity by saying who I am, and then finally configuring the witness. So pretty standard stuff there. Create an endpoint, port, etc. All right, have to validate identity to the witness. Pretty straightforward there. And then supply service accounts on behalf of each of the instances. Remember, they may not be the same accounts.
That's true.
Please tell me they're different accounts.
I was going to say, if it's best practices, they won't be.
Yeah. So I walk through the wizard, and there I go. There's mirroring. Now, the fun part, so it'll show progress. And then ask me if I immediately want to start synchronizing transactions from the principal to the witness. And it asks me if I want to start mirroring right now or maybe later on.
Okay.
Now, after, and by the way, I clicked on start so that it would have started. And this is when I get back to the mirroring page, and there is a significant button here. Notice the failover button.
Okay.
So the failover button allows me to manually failover and gracefully. So I might do this for something like a rolling upgrade. Okay. So I apply a service pack on the secondary, on the secondary machine, reboot it, make sure mirroring is reestablished, fail over to that one, rinse and repeat on the primary, and then get back to my original configuration. If I need very high availability, I have to have a technology like this. All right, so this is where I would have manual failover. It would probably be a little bit more dramatic to see, pulling the network cable on an actual machine that's being mirrored and see it automatically fail over. That would be kind of cool.
Yeah, but we don't have multiple machines.
All right. So if I did click on the failover button, we'd see failover database mirroring will swap the roles of mirror and principal, basically go through the rollover process, and that's it.
So what's the technology now that's replacing mirroring? Where are we going with SQL Server?
All righty. So the hot technology, really a game maker, is a new technology in SQL Server 2012 called AlwaysOn. And this will be especially noteworthy after we look at our final technology because it really overcomes all of the weaknesses of all of the other models, the other high availability technologies.
So this is the last of the SQL Server options for HA.
Yeah, yep. So we have the standard plan of attack here, basics, how we implement it, failover, etc. So first of all, this is a new feature in SQL 2012, and we'll see that it provides failover for a collection of user databases. So I can have what's called an availability group, define multiple databases, and have multiple copies. See, my mirroring copy was not readable, and I could only have one.
Yep.
Here, I can have multiple copies, and I can fail over multiple copies at once. There's lots to like about this. Really only one drawback, but that's another slide.
Yeah, I was going to say, wait for the strengths and weaknesses. Don't give it away.
A collection of primary replica databases support read-write connections. A collection of secondary replica databases, up to 4, support read-only connections, but it requires a particular Windows feature technology called Windows clustering. So we'll find also, just like with mirroring, that we can have synchronous commit mode. That means before a transaction is considered committed, it has to have already committed on all of the destination copies. That's synchronous, meaning marching in step. Asynchronous would mean I send a transaction log over to a destination, I continue business as usual, maybe it commits right away, maybe it doesn't. And then we also have planned and automatic failover with no data loss, other than maybe the transaction that was in progress at the time.
That is pretty cool. How do I get this going? What do I need to do to put it together and make it work?
So each instance hosting an availability group must be a Windows Server failover clustering node. I have to add the Windows clustering feature.
So this is an OS level requirement.
That is an OS level requirement.
Okay.
And fortunately, building or using the failover clustering feature has gotten a whole lot sweeter over the years.
Okay.
Probably no surprise. I have to have the same instance collation on all of the possible member copies in the availability group.
Okay.
And then I have to enable the AlwaysOn availability group feature on each instance, multiple ways to do that. After I enable it, then I walk through a wizard. It waves a wand. It waves a wand over a number of activities. You have to configure what databases you want to have as part of the availability group. Okay. You have to configure a database mirroring endpoint. Does that sound familiar?
Yeah, it does.
All right, so there's some familiarity there. Create an availability group listener, specify replica copies, and then select an initial synchronization option.
That's pretty cool. Now, what about failover? What happens with failover with AlwaysOn?
Okay, so we have a couple different, well, 3 different failover modes. Automatic failover, which would be the most glamorous of them, and other than maybe the current transaction that was in progress, no data loss. Like mirroring, we also can have planned manual failover without data loss. And then in the case where we have some serious problem, but not an automatic failover, we can tell it, well, these are my words, dang it, failover.
Okay.
So forced manual failover, possibly losing transactions. So,
and what happens when they do failover?
During failover, the failover target takes over the primary role, recovers its databases, and brings them online as the new primary. The former primary replica, when available, if it were to self-heal, let's say, maybe somebody did a server reset or something like that, will switch to a secondary, and its databases become secondary copies. Then, based on policy, the forms of failover that a given replica supports is specified by the failover mode property.
And so, okay, we've gone through all this. What are some of the strengths and weaknesses we can expect from AlwaysOn?
Alrighty, strengths. Very fast and automatic database and client failover like mirroring.
Okay.
Very flexible configuration with multiple failover replicas, unlike mirroring.
That's cool. So you get more than 1 DB at a time.
Read-only access to replicas, which we did not get with mirroring.
Yay!
Can back up replicas to offload work. So take my replica, which is transactionally consistent, put the backup load on it rather than the one that's serving production.
So now I'm distributing my resource load using the AlwaysOn, not just getting HA.
That's right.
That's cool.
No special hardware necessary, unlike another technology we're going to look at. And I can also span data centers because of having endpoints that are reachable across the IP subnets. And my own opinion, this is not particularly trivial.
No.
So that's it. It's not particularly trivial.
Yeah, it is an expensive option, but it gives you a whole lot of possibilities for both resource utilization and high availability disaster recovery.
As far as, I don't have a canned demonstration for this, but I actually can do better. Use Bing and find the URL for Microsoft Virtual Labs. I don't know if it's microsoftvirtuallabs.com or what. Somebody find that out. And there's actually a library of a bunch of different SQL Server specific virtual labs. They have 2 specifically on AlwaysOn. So guess what? You can put your own hands on it, run through those particular configuration labs. I think you'll find that interesting.
That is very cool, very cool. So what then is the last HA possibility that we've got here?
All right, the last one we take a look at is also tried and true failover clustering. Lots of places out there with failover clusters. So we have our typical blueprint here, basics, implementation, things like that. So let's take a look at the basics. With all of the high availability technologies, you must understand the scope of protection.
Yep.
What we're trying to protect. Now, what we're trying to protect with failover clustering is a hardware node failure. So should I lose all the power supplies of a machine, I have a motherboard meltdown, I lose availability of the hardware node, then the SQL Server service is going to roll over to another node and run on that machine. But keep in mind, the databases that are attributed to that particular cluster, as it's called, are not redundant. Their data is not redundant. The redundancy protection here is the server hardware node.
So we're not talking about data storage protection, we're talking about resource availability protection.
We are talking about hardware. Now, in order to implement this, I have a lot of hardware that I have to architect, and it's particular. This is partly opinion. Maybe somebody, there are others that might have other opinions. I think it's particular. So I'm going to set up my physical hardware first, install Windows, then I must implement a Windows failover cluster. It requires certain configuration, and then I'm going to add 1 or more additional nodes that will be part of the Windows failover cluster. The restriction here is that ultimately what I get is a portable name. I get a name that clients are going to connect to. That name and all the resources that pertain to it can run on one hardware node or can run on any other node in the same cluster. So only specific services and applications support this kind of behavior. So shared folders, a couple of other Windows key features, and then a couple of applications like Exchange and SQL Server. SQL Server, specifically with this, you must install after you already have your Windows cluster and some other things occur after the fact. Now, architecturally, in fact, let's jump to the architecture diagram, and I think this is going to help point out some other things. So notice I need at least 2 physical nodes.
Okay.
Well, even the virtualization, I can actually virtualize a cluster. That's way too complicated to talk about right now. So the picture you're looking at really is more typical of something I'd see a few years ago.
So two physically separate computers.
Yeah, 2 physically separate computers. Notice they're going to have a network adapter for clients to connect to. They're going to have a network adapter for their own personal traffic among those nodes in the cluster. And notice the heart there represents a 1.1 second packet. Every 1.1 seconds, the heartbeat packet is used to establish kind of a keep alive among the other cluster members. Now,
Okay.
the other part of this is that I'm going to have a storage area network. In the past, before SANs were popular, there were some other technologies, but essentially we have to have a technology that allows more than one possible box to control the same LUN.
Okay.
So this could be iSCSI, this could be a fiber channel, but I allocate resources such as a bunch of disks for data files, a bunch of disks for log files, and then I have another resource which is called the quorum. The quorum, or as seen in this diagram, I have to have a tiebreaker kind of resource that says this is the node that's actually in charge. In the past, this would be just another small unit of storage, like seriously a few megabytes on the storage area network. These days, and more typically and better, this can just be a UNC file share on some third machine.
Awesome.
And I would say that's more typical. All right.
Awesome.
So after I have all this hardware set up, and word on the street has it that you want these machines absolutely identical.
Yep.
You're not always told that, but you want the same firmware in your host bus adapters, same motherboard, same network adapters, in the same slots with the same amount of memory and memory speed. I mean, you want them as identical as possible.
So once you've got all that configured and everything's good to go, how do we then deal with the failover process itself?
A couple other little architectural elements. I have after my Windows cluster, install SQL Server, and the portable name here, the SQL cluster, is what clients will connect to. And then we have failover. Let's say I have a hardware node failure. There's going to be a policy that says, if I have more than one extra machine in the cluster, prefer to fail over to this one, and will I allow it to be automatic, yes or no?
Okay.
So failover is determined by a policy. Now, there has to be quorum or agreement among the nodes in the cluster as to who is actually serving the instance.
Okay.
So this could be determined by a couple different ways: node majority, node and file share, node and disk majority, disk only. So you have options there. This is expanded from what you might have had maybe 10 years ago.
All right.
Okay, brace yourself.
I'm braced.
Now,
give it a ride.
Essentially, when my cluster fails over, the SQL Server restarts, and if I have 100 databases on that instance, we know every time SQL Server restarts, every one of those databases has to go through the redo and undo process. So failover in the worst of cases could really be lengthy, which means it's not quite as attractive as always on or mirroring. But it protects the entire instance, which the other technologies do not do.
Awesome.
A good point is that there's zero client configuration. Clients point to a portable name. So this pretty much dovetails into the strengths and weaknesses. Clustering's been around for a long time. That means a lot of people know about it, have established policies of how to do it, and setting up the hardware or validating that the hardware will work right is done with a nifty wizard, the Windows Cluster Validation Tool. Weaknesses: specialty hardware required. It's more expensive. It requires more expertise. For those that don't know how to operate a cluster well, you may introduce the opposite of high availability. You may reduce availability by causing a problem.
Oh, yeah.
And then keep in mind, data is not duplicated with a failover cluster. So it's often the case, if you were to use this, you would combine it with one of the other technologies like log shipping or mirroring, or you're going to use AlwaysOn.
AlwaysOn. That would be the one.
All right, Rich, so that wraps up all the stuff that I had for today.
That's awesome. George, I want to thank you for your time today.
Thank you.
Appreciate it. Also, for those of you out here on the view watching us, in the bottom of your browser, there is a poll. This poll is probably the one that we really hope that you would add your feedback into. It really is how we know how well we did and gives us a chance to get better in future ones. Again, thank you so much for joining us today. For George,
Thank you.
and Rich, and everybody out in the back that helped out, Elise and Danny and Barry, thanks very much. Hopefully we'll see you again down the road. Have a great day. Whoa!
I want to put in a plug for your session on Friday.
Yeah, we'll see. We got another one coming up. Check the schedule on the web if you're interested. We've got data warehousing and SSIS in a day or two. Thanks again. Have a great evening, afternoon, morning, whatever it is, wherever you are.